Hi everyone, I hope you're all keeping well and are safe at home. In this video, I'm going to show you how we integrate a function. Integration is also known as anti-differentiation. Mathematical representation is this. We integrate a function ax power n dx because we are integrating ax power n with respect to x, where this part here is known as the integrand, and the result that we're going to get is going to be the integral. Okay, so integrate this function. So we integrate the integrand to get the integral. Okay, integrate ax power n dx is equal to. So we have here the index, the power. So we rewrite the function ax power n. Okay, so we increase the index by 1. So increase the index by 1. So ax n plus 1. And then we're going to divide by the new index, which is n plus 1. And then plus a constant c. We have ax n plus 1 divided by n plus 1 plus c. Okay, now integration. We have the indefinite integral, and then we also have the definite integral. Okay, we are going to focus mostly on definite integral. So let's see the difference between indefinite and then definite. Mathematically, indefinite integral means this. So if we have, again, if we see, let's take an example, 5x power 3 dx. Okay, so again, we're going to write the function. We add plus 1, and then we divide by the new power here, which is 4, and then plus c. So in definite integral, you will always have a plus c with it, which means it is known as an arbitrary constant. Its value is not known. It must always be added to an integral. Okay, so such integral is known as indefinite integral. Whereas definite integral means you're given the boundary of this function. Here there is no boundaries. That's why it says indefinite. This one is definite. So which means if I'm going to integrate this function, I'm going to have what? A lower boundary and upper boundary. 5x power 3 dx. It's going to be 5x power 4 divided by 4, but this time it's going to be a definite integral between a limit a and limit b. So basically we are interested with this formula: integration of lower limit a, upper limit b, ax power n dx. So this formula is going to be ax power n plus 1 divided by n plus 1 from a to b. Let's do further examples. I'm going to integrate. So let's take the limit for now, ab. 3x power 2 dx. Again, we are integrating with respect to x. That's why dx. Okay, so we have 3x, increase the power by 1, 3 divided by 3 between the limit a to b. Okay, so you can reduce to the lowest term, right? Now, this is a term, one term. But what if you have an expression? Integration between a and b. You have 2x plus 5 dx. Okay, so here you have an expression, one term plus another term. So whenever you have such function, such expression to integrate, we are going to consider one term at a time. So here again, so we have 2x, so it's power 1 here, power 1, 2, 1 plus 1, 2 divided by 2, plus, now here, so if you integrate a constant, it's going to be 5x directly. How we get that? 5x is also equal to 5 times x power 0, because x power 0, any value to the power of 0 is always 1. Now, if we are integrating this x power 0, which means we are adding plus 1, right? That's why we get 5x1. So, integrating a constant, c is a constant, respect to x is going to be cx. Again, a, b, oh, you can't see, okay, here, a to b. Okay, let's do a few examples. Okay, so for now, let's consider indefinite integral. Okay, to integrate, suppose s square minus 2s plus 3. Okay, so we're going to integrate this function, this expression. So we're going to work term by term. So here we have s square. So it's going to be s power 3 divided by 3 minus 2s, here power 1 plus 1, 2 over 2, and then plus 3, integrating a constant, it's going to be 3x. Again, we are considering indefinite integral, so we are going to add plus c, the arbitrary constant. Okay, another example, suppose we integrate this function, suppose x minus 1, 2 minus x dx. Now, before we can integrate this, we'll have to simplify the function. We'll have to expand the function. X times 2 we have. So integrate. So we have 2x minus x squared minus 2 plus this becomes 3x x minus x squared minus 2 dx. So what do we have? We have 3x squared over 2 minus x cubed over 3 minus 2x again plus c. X power 1 over 3 dx, and then between limit 1 and 8. Okay, the first thing to do is we integrate this term. Okay, so same principle, x power negative, so negative 1/3 plus 1 is going to be x power 2/3 divided by 2/3 within limits 1 and 8. Now before we replace the limit, let's simplify. 3 over 2 multiply by x 2/3, 8 and 1. Now we have a constant here, right? So we can remove it outside. So we have 3 over 2. Inside we are going to be left with x. This is known as the upper limit. This is known as the lower limit. So basically what do we need to do is, if we have a function f of x dx, we integrate f of x with respect to between limit a and b. So when we integrate this fx, we're going to get a new function, capital F of x, between limit lower limit a, upper limit b. So what do? Is we are going to replace the b, so we're going to take f of b minus f of a. Simply, if we have a function 2x minus 5, and then if you're asked to find f of b, what do? We're going to replace the x by b. So we have what? 2b minus 5. Similarly for this one. So we have 3 over 2, open bracket. We're going to replace upper limit first. So we're going to take upper limit 8 power 2 over 3 minus 1 power 2 over 3. So we're going to simplify this 8. It's the same as what? 2 power 3. We have, so 1 power 2/3 is going to be 1. So is equal to 3. So here we have this, then we have 4 minus 1, and then we have the answer 9/2. This is known as definite integrals. Next part we have integration of this type of function, this type of integration of ax plus b power n, where the condition is a is not equal to 0 and then n is not equal to minus 1. Again, integrating ax plus b power n dx. Ax plus b power n plus 1, we divide by the new index, by the new power, and then we're going to multiply by the derivative of the inside. So derivative of this times a and then plus c. Here you will need to know a little bit about differentiation as well. Okay, example. So integrate this function. 2x plus 1 power 3 dx. So we have 2x plus 1 power 4 divided by 4 multiplied by the derivative of the inside, which is this, plus c. So simplify 1/8 2x plus 1 power 4 plus c. Okay, now what if you have something like this? 1 divided by 2x minus 1 dx. Okay, now again, like I told you earlier, we have to make the power in the numerator. Okay, so whenever you have function like this, first you need to send the denominator to the numerator. So first we send this. Okay, so we have 2x minus 1, we add, so it's going to be minus 1. You divide by minus 1, you multiply by the derivative of the inside, plus c. So you have 1/2 x minus 1 plus c minus 1. Okay,